This video will show you the differences between a major in math and actuarial science and the opportunities that they can provide. According to pay scale, the average pay of someone who has a bachelor's degree in mathematics is $77,000. And according to the Bureau of Labor Statistics, the median pay is $70,000, which is higher than the average across all majors, which is $59,000. According to pay scale, the average pay of someone who has a bachelor's degree in actuarial science is $67,000. And according to the Bureau of Labor Statistics, the median pay of an actuary was $108,000 in 2019. However, something to consider is that it can take many years after graduating to become an actuary, since there will be a number of additional exams to pass. Also, the job market at the entry level is competitive. This could also be why math majors tend to earn more according to the data on pay scale, since math majors will have a wider range of potential jobs to qualify for. The Bureau of Labor Statistics predicts that the demand for mathematicians and statisticians will rise by 33% by 2029 compared to 2019. This is mainly due to the surge in data that companies have been receiving in recent years that they need people with mathematical and statistical skills to make sense of. Since mathematics is used in many different fields, a math degree should open you up to many different job opportunities. According to pay scale, the most common reported jobs people with a math degree report having are software engineer, data analyst, data scientist, math teacher, actuary, and a financial analyst. However, a math degree is a somewhat general degree that is not specific to a certain type of job in the way something such as computer science is to software engineering. If you do end up choosing a math major, this means that you should take courses from the field that you want to enter, do summer internships, and to complete projects related to that field as well, in order to be competitive when seeking a job. Many math majors go into software engineering after graduation. If you want to qualify for software engineering jobs, then it would help to make sure to take a class in data structures and algorithms, since the material from that class gets tested heavily in software engineering interviews. It would also help to try to get some internships as a software engineer while in college and to complete software engineering projects as an undergrad. The three most common reported jobs for people with a math degree, according to the data on pay scale, are software engineer, data analyst, and data scientist. All three of them involve the use of programming, so it would help to make sure to learn how to program regardless. Currently, data science is becoming a very popular career path among math majors, and more roles have been opening up to people with just a bachelor's degree. To qualify for data science jobs, it would help to make sure to learn Python programming, data analysis using the Pandas library, machine learning, and to complete data science projects as an undergrad, and to try to get some data science summer internships. You might find that your university does not offer classes related to data science or machine learning. In that case, it would be necessary for you to self-study using books and websites such as edX, Coursera, Kaggle, DataCamp, FreeCodeCamp, and Udemy. Also, completing personal projects is important because there is a lot you might not learn about in your classes that is actually important for jobs. For example, in your computer science classes, you might not learn anything about areas in web development, but there are a lot of software engineering jobs in web development. By completing some full-stack web development projects, you will be better able to qualify for those roles, and you'll have evidence of your skills. Similar things could be said for data science and machine learning. You'll likely have a hard time finding a job with just a math degree. However, a math degree combined with classes from computer science, data science, machine learning, and projects in data science, machine learning, and software engineering would be a much more employable combination right now, since all three pay well and have very strong predicted job growth. A degree in actuarial science will be specialised for becoming an actuary. This is good if you want to be an actuary. However, it can mean that it will make it more difficult for you to get jobs in other fields that you could have qualified for with a major such as statistics, computer science, or mathematics. Also, you can still get a job as an actuary without an actuarial degree. Degrees such as statistics, mathematics, and applied mathematics can be just as competitive for the job role, depending on the classes that you take. However, there are many skills that you will learn in the major that will still allow you to qualify for other job roles. This is mainly because you will be learning a lot about statistics, and you should also become proficient with Excel. However, you should also learn how to program in Python or R, since this will help you to qualify for analyst type job roles. According to the data on PayScale, jobs people get with a bachelor's degree in actuarial science includes actuary, actuarial analyst, financial analyst, data analyst, and an actuarial associate. Getting a minor in another field such as computer science could also help to broaden your job opportunities. As a math major, you can expect to take classes such as differential calculus, integral calculus, multivariable calculus, differential equations, linear algebra, discrete math, abstract algebra, real analysis, and number theory. You can also expect to have the choice to take other advanced math classes or to take classes from related disciplines such as computer science, statistics, and physics. An actuarial science major will have you taking courses from a number of different disciplines. Required classes you can expect to be taking can include calculus, linear algebra, 2 courses in calculus-based probability and statistics, computer science, economics, finance, business, and actuarial science classes as available. The math major is generally considered as being one of the hardest undergraduate majors available. It becomes especially hard when you enter your junior and senior year, since most of your classes will be proof-based, which tend to be much harder than the more computational classes. Actuarial science is also a heavy math and stats major that is not easy. However, the math in a math major will generally be harder. So overall, you can expect a pure math major to be more difficult than an actuarial science major. A math degree can open up many different possible avenues for yourself and can be a very good degree when combined with a more applied minor. This is because the mathematics taught in a math major is useful in a wide variety of fields, but you will need to supplement it with some field-specific coursework. A very good combination would be to major in mathematics and to minor in computer science. Doing this would open you up to roles such as in data science, machine learning, data analysis, and software engineering. Majoring in computer science and minoring in mathematics is also a very good combination. If you want to become an actuary, getting an actuarial degree might not be a requirement. Instead, it might be more appropriate for you to get a related degree, but to make sure to take the necessary classes to become an actuary and to make sure to complete the necessary actuarial exams while an undergrad. It might be the case that halfway through your time as an undergrad, you decide that you do not actually want to be an actuary. If you major in a more general quantitative subject, such as mathematics or statistics, it should be easier for you to transition towards a different field than with an actuarial major. If you do decide to major in a more general field, it will still be important to choose more employable classes and to complete personal projects so that you can be more competitive for specific job roles. Something to be aware of is that actuarial science will focus more on applying traditional statistics techniques to smaller datasets. However, each year companies are acquiring more and more data, This is making machine learning techniques used on large datasets in data science more and more relevant each year. Machine learning and big data are getting incorporated more into the actuarial degrees and the exams. However, it would still help a lot to make sure to learn Python, manipulation of big datasets using things such as the pandas library, and machine learning, so that you can also be competitive for data science type job roles. One more thing to be aware of is that actuarial careers can have good job satisfaction because they have good pay, moderate working hours, and low stress. However, they also tend to have low job meaning, since most of the jobs involve helping already wealthy people earn more money. Alternative careers, such as in data science, can allow you to have a more positive, socially impactful role, which should allow you to have a higher level of job meaning. When compared with a degree in actuarial science, you can expect a math degree to qualify you for a wider range of jobs. This should help you when looking for entry-level job roles, since you will have a wider range of potential jobs to qualify for. With that being said, being a general degree, it can make it difficult for you to qualify for specific job roles, and the jobs you will qualify for will depend a lot on the classes you choose in your time in the major. With that being the case, it would help a lot to make sure to take classes related to the type of job that you are interested in. If you are interested in a math degree, I would suggest leaning towards an applied math degree instead of a pure math degree. The reason for this is that an applied math degree should include fewer proof-heavy classes and more classes that are employable in the job market. Actuarial jobs are commonly rated as being some of the best jobs you can get in terms of pay, work stress levels, and working hours, but they can have low job meaning. If you are absolutely set on becoming an actuary, then getting a degree in actuarial science would be appropriate. In this case, it would help to try to minor in something else, such as computer science, since this will help to reduce your risk. If you are unable to find an entry-level job role as an actuary, or if you change your mind and decide that you do not actually want to become an actuary. However, if you are not absolutely sure that you want to become an actuary, it would likely be a better option to get a related degree, such as applied mathematics or statistics, but to make sure to take the relevant classes to become an actuary and to complete the necessary exams while you are an undergrad.